Our pilots at Virgin Galactic are the best of the best. They're test pilots with thousands of hours flying high-performance jets at supersonic speeds where they're making split-second decisions to do what they need to do on that high-performance vehicle. On a spaceship, you do need to optimize the design. Because of that, we've got to design our own custom systems to suit our needs exactly. That's where avionics comes in. I'm James Flynn. I'm Senior Director for Avionics Engineering at Virgin Galactic. Avionics comes from aviation electronics. It's literally the electronics that are in the vehicle. I like to say anything that has electrons flowing through it, that's avionics. Without the avionics system, the spaceship doesn't do very much. The avionics enable all the other systems to work. It's the nervous system of the spaceship. The sensors are its nerve endings. They pick up all sorts of signals. For example, temperature readings as the ship heats up when we accelerate through Mach 3. Strain gauges measuring various loads and forces, not to mention airspeed, rocket motor pressures, and control surface positions. The spaceship has hundreds of sensors. The wire harnesses are the nerves that run from every area of the ship to one of 6 brains called data acquisition units, or DAUs. Finally, the signal's processed by our central computers and is turned into information that the pilots can see, arranged on 3 multifunction displays, or MFDs.
Fire, fire! I'm Dan Alex. I'm a test pilot here at Virgin Galactic. For the spaceship to execute its mission, we are monitoring every possible part of the system. And they're all coordinated in a concert between the automation and the pilot to take all that information, simplify what the pilot needs to know, what the maintainers need to know, what the mission control needs to know, and what the automation needs to do on its own, have that all coordinated into our avionics. It's one of the most pilot-friendly and best designed interfaces I've flown in a vehicle.
The data relays from the sensor through the DAU system and send the pilot's displays in less than 30 milliseconds, the blink of an eye. We have the best avionics team in the world because we have to know every system. We have to be able to design every system. They're not your normal electronics engineers. They're digging into the propulsion system, flight control system, communication system, environmental control, the cameras for the customer experience. Those are all part of the avionics system. They know how to do more than software. They know how to design primary flight displays for pilots, and that's a special niche to be able to design those types of systems.
The flow of the overall avionics system, like a central nervous system, is data flows from the various components into what we call data acquisition units, DAUs. We have 6 of those on the vehicle. The DAUs in turn then collect that data and send either to computers on the multifunction displays that process that data, or to central computers, which we have 3 of. So we're triple redundant.
You can't just go buy avionics for a system as unique as Spaceship Delta. So we've developed a lot of our avionics systems from the ground up, from the flight displays to the data acquisition units to the flight control computer.
Something that I really love about these is they were designed to be very pilot-friendly graphics. They took a very complicated schematic and simplified it down so that you can interpret it very quickly.
Pilots come from the test flight world, and they know exactly how they want the spaceship to operate. At the end of the day, we're trying to do what's right, what's safe for the system. That's what comes to our guiding principle, safety above all. And part of that is making sure we've got the design to do exactly what it needs to do.
I'm Eloise Sinwell. I'm on the avionics test team at Virgin Galactic. I am part of the team that makes sure that all of our electronics on the ship work as we plan. Electricity and software work the same everywhere. That is something that we can rely on, and that's why we build these test benches in the lab, because we use that as the foundation of how we do our testing in here. So not only do we build test benches that need to emulate a perfectly functioning system, we build test benches that will also be able to inject any sort of failure that we might possibly see. We're going to try throwing in rapidly changing signals. We're going to try throwing in completely missing information and make sure that our system responds to that. Our most basic tests that we run are making sure that our components can withstand extreme vibration, extreme temperatures, and electrical surges. We're going to include both over and under pressurization tests. We take it very seriously. We're pushing these systems to their limits because we want to be sure that we know how our system's going to respond and that our system's going to be safe.
Knowing that you've tested enough is hard because you're looking for that empty space. How do you know what you don't know? We have to have some really smart engineers go through it and go through it again, double check everything. We have a brilliant product safety team. Now we can build a safe avionics system for Spaceship Delta because we've tested everything.
I'm Michael Smith. I'm the Vice President of Alpine Aviation Group. We're located in Ozark, Missouri. Right now we're in our fabrication facility. This is where we're building wire harnesses for Virgin Galactic spaceships. Most of the stuff we did in the past is military. We were doing Black Hawk helicopters. We get all the piece parts for the electrical harnesses, so all the wire, the connectors, the splices. We do all the hand-skilled stuff. We'll take the drawing that VG has made and we'll build the harnesses from scratch.
So the wiring harnesses are like the nerves of the spaceship. They're what's actually sending the signals between the different boxes on the vehicle. We start out designing them in schematic form, so the wire harnesses are all mapped out on the ship on the 3D model. They take our wire harness drawings, they print them out, put them up on a form board, and they start laying the wires out.
My name's Austin Smith. I am the production control supervisor. Humans are full of electricity too. We have our own natural wiring harnesses inside, so it's really cool to think about how, yes, it may not look like the coolest thing ever, but it's bringing something else to life. It's a big deal.
Some of them are 80 feet long or more. It's about 10 miles of wiring on the spaceship. So when we get the harnesses back, we go take it out to the spaceship and we literally put it up and bolt it in.
When we finally get to put all of those components onto our ship and we get to turn it on and see them working together, I think it's going to be pretty magical. I'm so excited to see this spaceship that I helped design and test come together. It's going to be incredible.
This Delta project is so new that I think everyone likes the idea of working onto something cooler. You start with a helicopter, an airplane, and you end up on a spacecraft. That's a pretty good progression.
There's just an unimaginable amount of complexity that the engineers have worked through and simplified.
We're not the only ones out there right now that have unique needs in the industry, because a lot of companies can't just go buy avionics off the shelf. And at Virgin Galactic, we can provide that expertise due to the capabilities to build world-class avionics that are cost-effective and optimized for what they need to do.
There is a level of, I can't believe I'm doing this, and it's awesome. I'm wiring a spaceship. Like, no, not that many people get to say that. This is how we build avionics. This is how we build spaceships.